Hello, we are going to go over the 3 skills from Chapter 12 that will be on the test this Friday. And then maybe at the end we'll have some time to go over some application type questions. First off, Friday, the test will cover those 3 from 12 and anything that is left over from Chapter 8. Okay, so make sure that you're prepared for any of those. So let's jump right into it here. Take a look at our first question. The first skill is about arithmetic and geometric sequences. Those are commas, not addition sign pluses, okay? So I'm going to ask you for 3 things. Tell me if it's arithmetic or geometric, so you need to know the definition of those things. I want the rule, and then I want you to find a specific term. So we're writing explicit rules here, okay, an explicit rule, so you can jump to a term. I'd like you to try this for number 1 and number 2. All right. Hopefully you had a chance to complete these. Question A we'll address right away. Number 1 is geometric, and number 2 is arithmetic. And at the same time, I'm going to bring down up here, I have the 2 general forms of the rules, which are helpful for question B, write a rule for the nth term. So let's take a look at number 1 closely here. The first term, that's going to be easy. It's 35. The R value is what are we multiplying each time. So in order to find the R value, I always like to think of it as just as simple as taking a term, putting that on top, and then dividing by the previous term. So for example, we could take -7 here. Okay, that's a term, put that on top, -7 on top, and then take 35, the previous term, put that on bottom, and this would simplify to -1/5. So we've got a1, we've got r, and geometrics are a little bit easier. There's not a lot to it. So here's 35. I'm going to replace that as a fraction. This is going to be a -1/5. And the n to the 1 just stays. You can't simplify this at all. Probably clean it up a little bit. Put a parentheses around this entire thing. But really, this is as simplified as you can get right here. And then the final question is to find the 14th term, which just simply means plug in 14. And I'm asking you to find a sub 14, which means you're going to plug in 14 right here. So there's a 35 out front, still a -1/5 to the 13th. And sometime, I mean, this is what I'm going to be looking for. This one's a little hard to multiply out because I think this number gets pretty small, but you can use your calculator to identify that. Over here in number 2, again, we've identified arithmetic. The 2 things we need for an arithmetic sequence is a1, which is -5. Identify that right away. And then the common difference, the d value. So what are we doing each time, whether we're going up or down? And it looks like this situation, we're adding 4. So our d is a +4, a common difference of 4. We can plug these things in. We do need to simplify here. So I'm going to change this, was a -5, and I'm going to substitute this as a 4. Do not leave your answer like this. You have to distribute this 4. Okay? So you'll distribute the 4, and it becomes 4n. And then there's a -4, and then that's a -5, so that makes a total of -9. Okay, and that's a sub n. And another thing about this is this -9, that you can think of as a sub 0 in a way, okay? A sub 0. Because if -5 is a sub 1, if we were to go backwards 1 more, it would be -9. So this is kind of your starting value, and this is where you go. But we prefer to use this rule here and then simplify to that. All right, So that's the skill for, oh wait, no, we need to find the 14th term, excuse me. A sub 14 equals, you're just going to plug in 14 after you simplify, okay, and then minus 9. And so you're going to multiply 4 times 14, subtract 9. You're doing this on your calculator. And you get 47. So that's the skill for 12A. Write a rule and then find the term. You need to memorize those two general forms so that you can plug them in, simplify, and then move on. All right. The last step then is to find the sum of series. Sequences have commas, series have addition in between, and so there's a couple of different ways we can do it. Here's a form written as summation notation, number 1 and number 4. Number 2 is infinite because it has a dot, 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 and so we'll have to check that one out. And then number 3 is not infinite, though it has a dot, dot, dot. It ends at this 1,953,125. Right. So I'd like you to find the sum of these series if possible. If not possible, DNE. Okay, hopefully you've had an opportunity to try those, and let's just kind of go through what are the different types. Well, number 1 and number 2 are common because of the infinite symbol here and then the dot 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 at the end with no term kind of appearing to cap that off. So what do we know about infinite sequence, infinite series? Well, here's the sum rule for it. All right, we need to find a sub 1 and we need to find r, but remember, r must be between -1 and 1. Okay, which means you have to check and make sure that you're okay here. We're going to take a look at number 1. It looks like this is in the form a sub 1 times r to the n minus 1, so we know our r value in this situation is 2/5. It checks out. Okay. So let me highlight that in here. Here's our r value. It checks out. So now it's really just as simple as plugging in the two values you need, a sub 1 and r. So I'm going to duplicate this over here. We will need this one again. And I will substitute in 3 here on top, and then 1 minus 2/5. And to simplify this, let's duplicate it again. 1 minus 2/5 is going to be 3/5. And hopefully you'll remember from chapter 8 that dividing by a fraction is really multiplying by its reciprocal. So best to say this is actually 3 times 5/3. Flip it over. So it was 3/5. Flip it over to 5/3. The 3's are going to cancel out, and this sum is simply 5. Right? And so I've left this infinity symbol here. That's not really necessary. We would just say that s equals 5. S equals 5. All right. Over on number 2, we don't have quite things as explicit. We just have the pattern. So I always like to try to break this down as, all right, what's happening in the numerator, what's happening in the denominator. In the numerator, it looks like we're multiplying by 3 each time. Okay, so it's 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. So if I'm looking for my r value here, I would say that r is 3 on top. Okay, so r equals 3 on top, and then what's happening in my numerator? So I'm 2 times what is 4, or 4 times what is 8? It's going to be 2, and so I have an r value of 3/2. Well, that's a problem because that is not less than 1. Okay, it's not. And so the sum does not exist. Does not exist. If you plug 1/2 in for a sub 1 and you plug 3/2 in for r, your calculator is not going to know the difference. Okay, it will divide and subtract and do all those things for you. You have to know when can we use this and when can we not. Number 3, this is a geometric pattern. We're multiplying by 5 each time. 1 times 5 is 5, 5 times 5 is 25, and so on. And so I'm going to pull my geometric pattern down here. The trouble with this one is I've got a couple of things identified. My first term is 1. All right, so that's not going to be a bad thing to deal with. R is equal to 5. But the thing that we're not sure about right now is n. Okay, what does that equal? Because I know that technically this is my first term, and then this is my second term, and this is my third term and fourth term. But then how far does it go? And so there's a couple of different ways you can figure this out. My favorite method is probably to just do the math. You never know how long it's going to go. You can always just type into your calculator. Hard to keep track of sometimes. We have what we need to write a geometric rule. So a sub n is 1 times 5 to the n minus 1. Okay, substitute that big number in. So it's 1,000. Actually, I'm sorry, 1,953,125 is equal to 5 to the n minus 1. And of course, we've got logarithms. How do we get an exponent? We have to take the natural log of both sides. Okay, this drops down. We have to divide by the natural log of 5. And so we've got this big number over here, and whatever that might be. This equates to 9. If you do that in your calculator, remember the parentheses around this big number. And then it's equal to n minus 1. Add 1 to both sides, and so n equals 10. This is the 10th term of that pattern. So number 5, number 6, 7, 8, 9 are not included. It's in that dot, dot, dot. This is the 10th term. 10th term. So we have everything we need now to plug into this formula, and I'll just replace them as I go. A sub 1 is 1. That'll eventually just disappear. This is 5 to the 10th over 1 minus 5. So the 1 is going to disappear. The denominator will simplify to a negative 4. 1 minus 5 is negative 4. And this numerator, it's going to be a really big number, but it won't be, I guess, impossible to calculate. It's negative 9 million, something like that. And then we need to just simply divide that by negative 4. And our final answer is 2,441,406 with commas there. So pretty big sum, but of course we had a number at the end that was close to 2 million already. So finally, number 4 is written in summation notation again for us. We like summation notation because it tells us everything we need. This is an arithmetic. It's just adding 3 each time. So I'm going to bring my arithmetic rule down here. You'll see this written a couple of different ways. You'll see it like this, or you may see an n out front and then this whole thing divided by 2. It really doesn't matter. It's the same function, same formula, just written in different ways. So we'll stick with the first one here. What do we have? What do we need? Well, n, what's our first value? Or how many terms are we summing up here? And it's 16. We're summing from the first term to the 16th term. What is the first term? Well, let me plug 1 in. Okay, so we take 1, plug it in. 3 times 1 is 3, and then 3 minus 1, that's 2. And the last term. Well, we're talking about the 16th term, so we need to plug 16 in. So you're going to take 3 times 16, that's 48, subtract 1 is 47. And you've got everything that you need right here in the formula, so plug those in. N, 16 terms. The first term is 2, the last term is 47. And you just sum those things up. and it equals 390.